Okay, so you had to work on a few of these word problems. Were they pretty exciting? No, they weren't exciting? Out of all the questions you saw, which one do you want to talk about? Yeah, Claire. Two. One, two. Volume of the cube. Express the surface area of a cube in terms of the volume of a cube. So here is a cube. What's the volume of a cube? If x is the side length. X cubed. Okay. What's the surface area of a cube in terms of x? 6x squared. There's 6 sides. Each side has an area of 6x squared. But I said I wanted the side length in terms of the volume. Well, she's asking about that one in terms of the volume. We know that v is equal to x cubed. So we want this surface area, but not in terms of x. We want it in terms of volume. How do you isolate, or what do you want to do next? You want to isolate something. You want to isolate x. What does x equal? Cube root of v. Now what do you do with that? Plug it in there, and you have the surface area in terms of volume is 6x squared, but instead of x, what do you write? Cube root of v. So if you have the volume of a cube and you want the surface area, you cube root it, you square it, and you multiply it by 6. Good. Yep. What's the second one you wanted to see? A second one. A second one you want to see it. You understand all the other ones? 47? Okay, 47 seems like a good one to do. 47, I think it's a rectangular box with a square base and an open top. How should you start this question? What should you do first? Yeah, draw a picture. So you have a square base, and the height does not have to be the same as the base. That's a terrible box. This one's not going to be that much better. There it is. Well, the side lengths are all x and x. Do we know the height? No. No. Let's call it, not LH, let's call it H. What's the volume of this box? 2. But we know volume is also equal to length times width times height. So in this case, the volume is going to be? So volume is x squared h. But I wanted the volume just in terms. What is it asking for in this? The area of the surface in terms of yeah. Let me actually clip that in. I'm sorry, I should have done that at the beginning. So you want this. That's the question. Sorry. So you want the surface area in terms of the length of a side. So that's volume. The surface area, what's the surface area of this? It's going to be in terms of x and h. What's the surface area of the base? How many other sides are there? 4. Are they the same or different? 4xh. So this is what we want, but what's the problem? H. We don't know h, but what does volume equal? 2 equals, so what can we solve for? H. So what does h equal? Now what do we do with that? Yeah, we eject to surface area just in terms of x is x squared plus 4x times 2 over x squared. What does that simplify to? Yeah. Yeah, good. Good. So that's the surface area just in terms of x. That's the surface area just in terms of x of a box of volume 2. What could be a second part to this question? What could, based on what we've learned before, section 1, in unit 1, what's one more thing we could ask on this question? What could be a part B? No ideas? The domain! Good job. So what's the domain, Claire? If I just gave you this function, what's the only number you can't plug in? 0. Yeah, that's correct. realistically, x needs to be greater than 0. Can x be negative realistically? No, x is a length. So realistically, x is greater than 0. Okay, so that, we could ask the domain. Now, in terms of this question, what might it be useful to know about this box? Well, it's always going to contain 2 meters cubed. But what changes as the shape of the box changes? Yeah, the base will change. What else changes? Okay, so the volume stays the same, but the what? The dimension changed. So the overall, what were we wrote 2 equations. We wrote an equation for volume and an equation for... so the volume stays the same, but what happens to the surface area? If we're going to make this box, what might it be nice to know? If we're actually going to make this box, what would be nice to know? If the surface area changes, but the volume stays the same, what if we're going to actually pay money to build this box? Smallest surface area, yeah. So we want to minimize the surface area. Now, is this a quadratic? Is it a linear function? What is this? Is it a quadratic? No, not because of that, right? Is it a linear function? No, this is kind of a weird... This is not a linear function. It's got a square in it. It's kind of weird, right? If we wanted to find a minimum value, what are we going to have to use? Okay, you have no algebraic method to use, so what are you going to have to use? Your calculator, exactly. So if we go to y equal... Oh, look what's already there. If we graph this thing, that's what it looks like there. I'm going to expand the window a little bit. X to the negative 10. This function spikes down, and then it goes like that. So this function pumps out values on the left side here, but that's for negative x values. Why do we not like negative x values in this question?
It's not real.
It's not real. Why does that matter? It's a length. Yeah, exactly. So we're only really looking at, we really want to know when x is 0. So it does this. As x gets bigger, the surface area goes down, and then it starts going back up again. How big could we make this box? And still have a volume of 2. How big could we make it? How big could the base be?
Is it infinite?
Yeah, as big as you want. Think, it could be 1,000,000 miles by 1,000,000 miles, and then how tall would it be? Itty, tiny, right? So you could use as much surface area as you wanted, right? So we want to minimize this. So how do we go about finding the minimum of this function? Zoom. So we go to calc, minimum. It asks us for the left bound first, right? Yeah. So we got to click over, and I always have to be careful about clicking too many times, or the cursor goes for a walk without me. Left bound, right bound, and guess. What does this tell us? If you had to write a sentence to answer that question, what does this tell us? Someone raise their hand and tell me exactly what that means. What do those numbers mean? Use a complete sentence. No one can tell me what those numbers mean? Okay, what was the x-axis, everybody? That was x. That's the length of the... Okay. And what's on the y-axis? Nope. Surface area. No. The smallest surface area is the minimum. Well, not say small. The minimum surface area. The min surface area is 7.559 or 7.56, and it happens when what? When the length of the base is 1.56 or 1.56. I like going to 3 decimal places when I can. Now, if you later when you take calculus, you're going to learn how to find the minimum by hand. This is what the work looks like, just to give you a preview. Surface area of x is x squared. Oh wait, that's an x. plus 8x to the negative 1. S prime, which you'll learn about in calculus, is 2x minus 8x to the negative 2. 0 to x minus 8 over x squared. So 8 over x squared is equal to 2x, which means that 2x cubed is equal to 8. So x cubed is equal to 4. So x is equal to the cube root of 4. Look at this, everybody. Let's quit this. 4 to the, how do I do 1/3? Just 1 divided by 3. That's cube root. Press enter. What was x? Ah, pretty cool, huh? So you're going to learn how to do that in calculus. Are you excited? You're excited. I know you are. Okay, your homework. First part is to totally understand numbers 43 through 47 from homework packet 1. And 2, unit 1 test corrections. I'm going to give you at least in the next 15 minutes to ask each other questions about the unit 1 test.